Here's another example. Before we do, let's let m this time equal, say, well, let's see what happens if we just do 2, 2, 2, 2. Okay, I mean, it would seem like it would just be doubling everything, right? And maybe it does. But let's see what happens. Okay. Well, we can go right to the characteristic polynomial here. So we sort of omit all the details and go straight to 2 minus lambda 2, 2, 2 minus lambda equals 0 for the characteristic equation. So we can write this out using the formula as 2 minus lambda times 2 minus lambda minus 4 equals 0. Then this is the characteristic polynomial, and we can write that out as 2 times 2 is 4, minus 4 lambda, because the cross terms, plus lambda squared minus 4 equals 0, right? So that the characteristic polynomial is lambda squared minus 4 lambda equals 0, and you can factor it the same way we did before, as lambda minus 4 equals 0, right? And then you can see that things are going to pretty much work out the same way, that the eigenvalues would have lambda 1 equals 0 and lambda 2 equals 4, right? And that you're going to end up then with so that we're going to let's do a more interesting example. For eigenvectors. Okay. Well, let's try, how about 1, 4, 2, 2 as our m, okay? And okay, so why don't you guys practice this? Why don't, first of all, what you do is write down the the formula that you would get, then with the DET in it. Write down the characteristic equation with the DET in it. So you sort of practice getting it that far. And then I'll wait a second, and then I'll do it. So you can we'll sort of be doing it in parallel, but I'll let you sort of go first.